Hey everyone, welcome to this YouTube channel, and in this video in the next 5 to 10 minutes we are going to learn an important concept of digital electronics, which is the binary coded decimal number system. Now the binary coded decimal number system is also known as a BCD code, and the other name given to it is 8421 number system. So it is basically, that means that each decimal digit 0 through 9 is represented by a binary code of 4 digits. So the designation 8421 basically designates the binary weights of the 4 bits, that is 2 raised to the power 3, 2 raised to the power 2, 2 raised to the power 1 and 2 raised to the power 0. So in this, basically what happens is, let us say if we have a decimal digit as one of the columns, let us take this as 0, then 1, 2, 3, 4, 5, 6, 7, 8 and 9. So here I've written all the possible decimal digits that we have. So what happens in a BCD or a binary coded decimal number system is that for each single digit a code is fixed. So for example, if we have 0, so this is represented by a group of 4 zeros. Then we have 1, so this is represented by 0001. Similarly, 2 would be represented by 0010, 3 would be represented by 0011, 4 in this case would be represented by 0100, 5 in this case would be represented by 0101, 6 in this case would be represented by 0110, 7 in this case would be represented by 0111, 8 would be represented by 1000, and last but not the least, 9 would be represented by 1001. Now if you're wondering how does this kind of a system come into existence, all they are doing is basically calculating a 4-digit binary number and then converting it into a decimal equivalent. Now let us say if we have to convert a particular binary number into its decimal number equivalent, all we have to do is just replace it by the digits. So let us say if the number is 843 and we have to convert this decimal number into its binary coded decimal. So here the number that we have is 8, 4 and 3. So this one is inside, let me write a 10 here. So this basically indicates that this is a decimal number system. So if we need to convert this into a binary coded decimal number system, all you have to do is just directly write the codes of 8, 4 and 3. So for example, in case of 8, which is the first one number here, the code is 1000. So I'll write this as 1000. Then we have 4 over here. So 4 is represented by 0100. So this would be 0100. And the last but not the least, we have 3. So 3 is represented by 0011. So 0011. So this right here is technically the BCD code that we are looking for. So we'll write BCD over here. So it's pretty simple that way. All you have to do is just replace the digit by its equivalent BCD, and directly you'll have your conversion. Now let us say take one more example. So let us take the second example that we need to convert is 8620, and let us say this is in decimal and we have to convert this into a BCD number system. So let us write the digits first. So here we have 8, 6, 2 and 0. Now let us replace the first digit, which is 8. So 8 is represented by 1000. So this would be 1000 over here. Then we have 6. So 6 is represented by 0110. So this is 0110. Then we have 2 over here. So this is 0010. So 0010. And last we have a 0 over here. So now since all the numbers are going in pair of 4, so even 0 would be accompanied by 4 zeros. So this right here is the BCD equivalent of this particular decimal number. Now let us take one more example, and in this case let us take a little higher concept. So first let us convert, let us say 175. Now this is a decimal number system that needs to be converted into a BCD code. So right here what we have is 1, 7 and 5. So I'll write this as 1, 7 and 5. So the first one is 1. 1 is represented by 0001. Then we have 7. So 7 is represented by 0111, 0 1 1 1, and then we have 5 over here. So 5 is represented by 0 1 0 1, and then we'll write this as BCD. So I hope in these 3 examples it is pretty simple and in fact pretty obvious on how we need to convert kind of a decimal number system, a BC decimal number into a binary coded decimal. So I hope that this video was informative enough, and for more such videos don't forget to subscribe to our YouTube channel. Thank you so much for watching. Goodbye.